Here's the 2013-14 winter outlook for northeast Iowa, southeast Minnesota, and western Wisconsin. My name is Jeff Boy. I'm one of the climate focal points here at the National Weather Service in La Crosse, Wisconsin. In this presentation, I'll be looking at the Climate Prediction Center's winter outlook for the area, what was this outlook based upon, and potential wildcards that may affect this upcoming winter. As far as the temperature outlook goes, the Climate Prediction Center is forecasting below normal temperatures for northern and western portions of Minnesota into the Dakotas. Meanwhile, there's equal chances of above and below normal temperatures for southeast Minnesota, northeast Iowa, and western Wisconsin. The precipitation outlook for the entire upper Mississippi River Valley is for equal chances of above and below normal precipitation. What this outlook was based upon, the Climate Prediction Center specifically looks to see what's going on across the central equatorial Pacific, specifically between 170 degrees east longitude and 120 degrees west longitude, and then looks at 5 degrees on either side of the equator. This area is specifically called the Niño 3.4 region, and it has been found to affect what goes on across the entire globe as far as temperatures and precipitation. If this area is in white, that means the water temperatures are near normal, and that's the case what's going on now and what is expected to continue into the upcoming winter. And this is called neutral or La Nada conditions. Meanwhile, if this area saw oranges and reds taking place, we'd see above normal water temperatures, which means that we would be seeing El Nino. Meanwhile, these areas were in blues, which means water temperatures were below normal, we would be seeing a La Nada. Looking specifically at the 20 La Nada winters that have occurred since 1950. Looking at the temperatures for the La Crosse area, 10 of the winters saw below normal temperatures and 9 seen above normal. As a result, there's no strong signal here at all as far as what's going on. So as a result, it's not surprising that the Climate Prediction Center went with equal chances of above and below normal temperatures. Looking at the precipitation, prior to 1989-90 winter, there was a strong tendency that we would see below normal precipitation during these winters. Matter of fact, there was only 2 that saw above normal precipitation for them. Meanwhile, since that winter, 5 of the last 7 have seen above normal precipitation. So does this trend still exist? It's uncertain. As a result, the Climate Prediction Center went with equal chances of above and below normal precipitation across the region. Now, the Climate Prediction Center does not do any forecasting for seasonal snowfall, and the seasonal snowfall runs from July 1st through June 30th. But we wanted to show you the slide to show you how variable the snowfall can be during these seasons. We have seen as a low of 7.7 inches during the winter of 1967-68 snow season to a high of 78.7 inches during the 1961-62 snow season. As a result, there's like a 71-inch difference between these two. And also, when you look at the below and above normal snow seasons, 11 were below normal, 9 were above. So there really is no strong indication here either. Another thing that the Climate Prediction Center looks at is what's happened during the past 10 years as far as temperatures. 6 of the last 10 winters have been above normal, and 4 were below normal. So it's almost 50-50, so really no strong indication here either. Another reason why the Climate Prediction Center went with equal chances of above and below normal temperatures. Looking at the precipitation during the past 15 winters is another thing that they look at. Prior to the 2006-07 winter, a majority of them were either seeing below normal or near normal precipitation. However, since the 2006-07 winter, the majority have been above normal. So is there really a trend here or not? It's still too short of a period to be certain. As a result, the Climate Prediction Center went with equal chances for above and below normal precipitation across the region. Looking at the snow seasons, and this is actually specifically since December 1st through February 28th or 29th, depending on whether it's a leap year or not. And just wanted to look at how much snow has fallen during those winters. And a majority of them prior to the 2006-07 winter were below normal. There was only 2 that were above normal for that time period. And since then, it's sort of the opposite of taken place, where a majority of them have been where we've seen lots of snow occurring during the winter months. And only 1 has actually been below normal, and that was the 2011-12 winter. So, is there a trend here or not? Too short of a period to really tell. Now let's look at the storm tracks that we tend to see during La Nina winters. The main snow track tends to be from Canada moving southeast into either the northern plains of the upper Mississippi River Valley, then diving into the Tennessee River Valley, and then out to sea into the Atlantic. Now, the storm track can be either west of us, which in this case we would tend to see colder than normal temperatures. Meanwhile, this track was to the east, more towards Michigan. We would tend to see warmer than normal temperatures. Looking at the second storm track that we tend to see, we see low pressure systems come into California, move east into the Texas Panhandle, then turn to the northeast towards the upper Mississippi River Valley. If these low pressure systems pass to our south, we tend to see lots of snow from them because they tend to pick up a lot of Gulf moisture from them. However, if the low pressure system tends to be further to the west, we tend to see more rain from them. The third and final track is not quite as common as the other 2. Matter of fact, it's fairly rare, where you just have a low pressure system track from west to east across the country. Now we'll look at the potential wildcards that can affect this winter. First of all, lack of snow is a huge factor as far as what goes on. And when we have bare ground, 80% of the sun's energy goes into warming the ground, which in turn warms the air above it. And as a result, we tend to see warmer temperatures. Meanwhile, if we have a blanket of snow at least an inch on the ground, 55 to 90% of the sun's energy is actually lost back to the atmosphere. It's just reflected right off, and very little goes into warming it. Matter of fact, a lot of the sun's energy that does make it to the ground goes to melting the snow. And as a result, we tend to see colder temperatures. Looking at the lack of snow just for the month of January, looking at the daily temperatures, you can see a huge difference occurring where the red squares actually are indicating days in which there was no snow. Meanwhile, the pink triangles indicate days that there was snow. And you can see that there's a considerable difference between these 2 out there, where when you have no snow on the ground, you tend to be quite warmer than if you have snow on the ground. Looking at the low temperatures, we see the exact same thing occurring. And looking at just for the month of January alone, the difference between having no snow on the ground and having snow cover on the ground, there's at least a 10.4 degree difference occurring. And the low temperatures are even a little bit more, where you're actually even 12 degrees warmer. Another thing let's look at is what has happened during the 20 coldest winters and the 20 warmest winters since 1893. When we've had the cold winters, the average snow depth throughout the entire winter was 6.8 inches. And when we've had our warmer winters, the average snow depth was only 1.6 inches. This is a difference of 5.2 inches. Looking at the number of days with at least 1 inch of snow on the ground, during the 20 coldest winters, the average was 76 days. Meanwhile, the warmest winters, the average was 42 days. So there's a 34-day difference between these 2. So snow is a big factor as far as what our total average seasonal, what we expect as far as temperatures go for an entire season. Another potential wildcard is the Arctic Oscillation. During its positive phase, low pressure is located near the poles. Meanwhile, high pressure is located in the mid-latitudes. This tends to keep the coldest air near the poles, and as a result, the mid-latitudes tend to stay milder. Meanwhile, when there's high pressure near the poles and low pressure in the mid-latitudes, we tend to see Arctic intrusions come into the mid-latitudes. Another thing that we look at is the North Atlantic Oscillation. And this is basically whether there's high pressure, where the high pressure and low pressure are located over the North Atlantic. When there's low pressure over Iceland and high pressure over the Azores, this is called the positive phase. Meanwhile, when there's high pressure over Iceland and low pressure over the Azores, this is the negative phase. During its positive phase, temperatures are warmer over the eastern half of the country, including the upper Mississippi River Valley. Meanwhile, when it's negative phase, we tend to see colder than normal temperatures across the eastern half of the country. Another thing we look at is enhanced thunderstorm activity that circles the globe near the equator. And as this progresses eastward, anywhere from 30 to 60 days, it has a great effect as far as temperatures and precipitation across the United States. When the thunderstorm activity is located over the Atlantic into the Indian Ocean, we tend to see colder than normal temperatures across the upper Mississippi River Valley. Meanwhile, when this enhanced thunderstorm activity is located over Indonesia and into the Pacific, we tend to see warmer than normal temperatures. As far as precipitation goes, we can see a rather active storm track when the thunderstorm activity is located across the Pacific. And this brings an end to this presentation, and thank you for listening.